Hi, my name is Dmitry, and today I want to show how I've implemented interactive water in Unity3d. First of all, let's look at the result. So here's the plane. You can create waves in it. It supports reflections. Also, it receives shadows. The shadows follow the geometry. It reacts to the global illumination. It supports imaginary boundaries. So right now I've created it right here, and no wave will pass it. They will be reflected. Also, it supports slow motion time. Right now it's 10% of real time. So I think that's it. Now let's look at the technology behind it. First of all, the physics simulations run at 15 frames per second with graphics bleed. It requires 2 render textures to store the state of the surface. It also requires 1 texture for obstacle map, like the imaginary boundaries that I shown before. The calculations itself, just a simple fragment shader with 6 texture lookups. Besides that, you have to recalculate normals each frame. Without the recalculation, the water movement wouldn't be so smooth as you want. The recalculation shader is also a fragment shader with 5 texture lookups. The shader that renders the surface of the water itself requires 1 more texture to decode recalculated normals into real world space normals. It also requires 1 texture lookup in the vertex function and 2 texture lookups in fragment function. Also, I use lookup into skybox cube texture. There is also a second camera used to render all reflections from the water and 1 additional render texture. So that's it, and right now I will go into the details of implementation. First, I will explain how the simulation works. So the main idea behind the physics is to represent water as a square grid and store all values that later will be used for simulation and for rendering in square texture. So the texture in itself looks like this in my project. So each channel used to store some piece of data that later will be used either in simulation or in rendering shaders. And for example, here the red channel represents the height map of the water. The green channel represents the speed of each point of the water. Then other 2 channels used to store some information that later will be used to reconstruct world space normals in the water. So if we have a texture that stores all this information, we can process it each frame with the function graphics bleed here. Here I'm using two textures because you really can't bleed one texture into itself, so you have to have at least two of them and swap them repeatedly. So here's the code for this, and the material that is used, described by the simple fragment shader. And the main idea here is to imagine that your water grid is a grid of springs. So based on the position of all pixels around your pixel, you can compute the force that will move your point on the water upside or downside. So you have to have some parameters like Hooke's constant, damping coefficient that will be used to make waves smaller with time. And also I used, of course, delta time because I want to be my water operate on different speed. And also I used some kind of additional force that will bring the water surface back to the center, because if you just use the model of grid of springs, then if you throw some part of your water, for example, down to make a wave, then all your surface will eventually go down. So you have to have a force that will return each piece, each vertex of your water back to the center. So this fragment shader, which is used for physics simulation, it should be run in constant frame rate because it's physics, and it only computes height and velocity of each point of the water in our water texture. Next, we should display it and we should make it smooth regardless of the frame rate, real frame rate of your game. So the next thing that I want to show you is interpolation with velocity. So if you look at the mesh and turn on the slow motion, you can see that the texture updates very rarely, but still the vertices moves smoothly. It's because the shader that depicts the surface of the water, it not just take height of the vertex. It also takes into account the velocity of it and the final height at which the vertex will be is calculated based on the time that passed since the last physics update. I mean the update of water texture. So the next problem you will encounter if you want to implement such kind of water is you have to compute normals to your water surface, and you want to do it each frame, not only when physics physics shader runs, because shading of your water surface is very sensitive to the direction of the normal, especially reflections. So if you want your water to be smooth and at the same time the physics shader runs not at very high frequency, then you have to implement another shader that will recalculate normals for you each frame. But actually my shader is not calculating normals, it only calculates the steep of two adjacent pixels, I mean difference of heights of two adjacent pixels on my map texture, and it saves those values into red and alpha channel of my water texture. And lately the water surface shader will reconstruct world space normals based on that information. So, okay, I've explained everything that is related to physics and normals recalculation. So now we assume that our water texture, I mean the texture with water data, is updated each frame. It has consistent normals information, height information, and velocity information. And note that height and velocity updated 15 frames per second, and normals information updated 60 frames per second, or whatever your game run. So right now we are moving towards the surface shader of the water. First, very short trick to modify the geometry based on the information in some texture. So here is the shader that renders the surface of the water, and here in the vertex function I actually look up into my water map, and based on that information I change the vertical coordinate of the water. So that's how the geometry is changing based on the physics calculations. So the next problem is to show reflections in your water. My approach is to use another camera to render my scene from behind the water. So here it is. It looks upwards, renders this picture, and passes the resultant texture to my shader that rendering the water surface. And in the water surface shader I have to compute screen position of each vertex, and lately this information is used to sample from this reflection texture. The next question that arises when you are trying to rendering reflections is the coefficient that you will use to blend your reflections and the real color of your water. And the basic approach is to use Fresnel formulas. You can find it in Wikipedia, and the approximate graph for it looks like this. So it's a dependency of reflection coefficient based on the angle of view. So the angle between your eye looking at the water and the normal of surface at this point. But because I don't use high dynamic range textures, I came into conclusion that the reflections with real physics formula looks not so good as if you make reflections higher on the lower angles of view. So here gray color depicts the formula that I've used here in this project, and it looks plausible. And the code for this formula is very simple, and if you want, you can use this formula, which is far more physics-based. So it's blue curve here, and in orange there is a real Fresnel coefficient formula. The other little trick that I've used is I both sample the reflection texture and skybox cube texture. So I use them both because when you make large waves, so for example here the reflection goes in the direction that can't be covered or rendered by the camera below, and the color of reflection should be not what you can see from here. I mean, here it's yellow, but if you look in that direction, it should be purple. So when I render the scene from the second camera, I don't use a skybox, and based on the alpha value of that texture, of that rendered texture, I blend the reflection texture and sample from skybox. So if there is no object here in the reflection, then I use skybox color from the real reflection direction. The next question is how to make your water react to global illumination and to global light direction. So here, if we rotate the light source, then we get different colors for our water, and this color is also based on the Fresnel formula, because you know, the light that goes to the water is based on the angle at which the light ray falls on the water surface. So I just tint the real color of my water with black color so here is the shader, and I blend the real water color, which is this, with black based on the coefficient of the light that should pass from the source to the water behind the surface. The other two effects that I added to illuminate my water are, first, I'm changing the color of my water based on the height of the wave. So if the point of the water is too low, then it gets less light, so it should be displayed with more dark color. And the other one is to apply this Fresnel formula not just locally to each point on the surface, but also globally. So if we take into account only what I call global normal, which is directed simply in y-axis, then all your water will have the same color. But if you want to take into account that if your water surface is rotated towards the light source, then it should be lit more brightly because more light goes under the surface, and then you can compute watercolor based only on local normals, which you are computing each frame with a special shader. But in this case, the result will not be so beautiful, so I blend those two values from normal, from global normal and local normal, and you can see the result. It's better than just using only global value and only local value. The last question is introducing obstacles to your water surface. So if you want to create some imaginary or not imaginary boundaries, for example, a large object is blocking water from passing it, then you can tweak your shader that computes physics, and it's not very hard. You just use another texture where you store the information about those boundaries, and in my case it's just coefficients that are applied to my computation of the final force that is computed based on the average of surroundings and your position. And this computation is controlled by this parameter, which is sampled from control texture. And different channels from the texture affecting different axes when you are computing average of neighbors. So I won't explain it into all details. You can look at the code and I will reproduce it. So here's the function, and here we are sampling our control texture and passing it here. So I think that's all for today. I've revealed the most valuable tricks of my water system. I can say that it works on the most of mobiles I've tried it to work on, and the main restriction here is number of vertices of your water surface. Besides that, you can use it on mobiles. You can try this water system in action on my website CraveForGames.com, where you can select Play WebGS build of Stone Drop game. And if you select any of the level, you will see this water in action. And here you can interact with it if you press mouse button here on some cell and then move it to other places without releasing it. So also you can go to my Facebook page where I post different articles like that, but in text format. So thanks for watching. Bye.